All right, so we're going to talk about energy of phase changes today. We have talked about just changing within the same phase, but now we're going to talk about these phase changes. Remember back to chapter 12 where we talked about your most cherished topic, intermolecular forces. Yes. Intermolecular forces then are being either reduced if you are adding heat, or they're being increased if you're removing heat. And you can figure out the change in that process by using a handy dandy equation. Okay. So you're going to be given, when you're doing this, you're going to have either heat of formation or heat of vaporization. Or if it's in moles, it'll say molar heat of vaporization or molar heat of formation. Okay. So when a change takes place, those intermolecular forces, if we're going this direction, are being reduced. If we're going this direction, they're being increased. Yeah, I can't come up with the words today. Okay, and you guys should be familiar with the fact that where you see these plateaus, because during a phase change, the temperature does not change. Very good. Okay.
Chad, please. I can't believe you got to see me.
What?
So when you are given these, they're in heat of vaporization, and they're going to be like it. You have to look at the units to see what you're working with. Okay. So these units are in kilojoules per mole. Kilojoules per mole. They want to calculate the heat to freeze. So is that going to be in this area or in this area? Are we going to use heat of fusion or heat of vaporization for this problem? Fusion. And I keep that kind of straight in my head because I think of these molecules as like fusing together and becoming a solid. So that's kind of the way I visualize it to keep these. And then vaporization makes sense because like it's turning into a vapor. Okay. So they have given us here our heat of vaporization at 58.6 kilojoules per mole. But they've given us our mercury, or I'm sorry, we're doing heat of fusion. It's this one. So 2.3 kilojoules per mole. But they've given us our mercury in grams. So what we need to do is we need to start with what we're given. We're given 100 grams of mercury.
HG, baby.
I need to get those grams into moles.
Okay, so you got to get the molar mass.
And then once I do that, I can figure out, okay, I've got this many kilojoules per mole. I'm getting this value from the graph here. And this I'm getting from
the periodic table.
Periodic table, right. So for mercury, it's 200.6, it looks like to me. Okay, and then all you have to do is run that through the calculator.
I lost my calculator.
Do it in your head though. I lost my AirPods.
You did? Actually? I did too.
I dropped them and I think I left them in the locker room, and I went back for them, and the kids in there were playing the game who could get each other's pants down the fastest. So I think that they would not be honest if I asked, so I just gave up.
That's so
exciting.
sad. You use those things every day. I had to go to a stupid seminar over the weekend. I hated it.
What for?
You were in Iowa?
All right, questions on this guy?
I've been to Des Moines.
Dimensional analysis.
I knew it would be coming back. I told you.
Yeah, dimensional analysis does not ever leave. All right, so you've got time. I think, Mel, look at the calendar there. I think we were just doing this today, right? Is that correct? Just 15:5? Okay. So 15:6 is tomorrow, and then we start our final exam review. All
When do we
right.
start our final?